All right, let's try to finish up this review for chapter 6. And I think there was a couple things after this, right? Didn't it go to 6:6? Right? Not what? Right. Not 6:7. All right. So let's take a look. Yeah, so this is just the quiz. Again, I'm not gonna actually do all the problems or any of them. We didn't go over this. Seems like we had some. Oh, okay, I see. Because in the first quiz, what they do, they told you that this was a parallelogram and then solve for x and y, right? This is kind of the same thing. As far as the math is concerned, it really is exactly the same thing. But it's a subtle difference. What are you doing? You're finding what x and y would be equal to in order to what? To make that thing into a what? Parallelogram. Oops, I better change my color here so you can see me writing. There we go, and let's change this to that. Okay, so yeah, we want to find what x and y is equal to in order to ensure, right there, ensure that this thing is a parallelogram. So the math is exactly the same as we did on the last quiz, all right? So what do we do? In order to say this is a parallelogram, what must be true about it? The opposite sides must be what? They equal. So what do? Set it equal to each other. And then what do? What's that? Well, you got to solve for x first, right? And then once you solve for x, then you can plug it back in. You can plug it into this one, or you can plug it into this one. Doesn't make any difference because they're both going to be the same. I would put it into this one, wouldn't you? Once you get x, yeah. And then you do the same thing with y. All right, so these two are across from each other. So if this was a parallelogram, in order to make it a parallelogram or ensure that it's a parallelogram, then these two opposite sides would be equal to each other as well. So you set them equal, solve for y, plug it back in. Actually, you don't have to plug it back in. I lied. Why? Because they only asked for what? X and y. Okay, so they only asked for x and y, so you don't have to plug it back in. You don't have to find the lengths of the sides. All you got to do is just solve for x and y. Everybody good with that? On the quiz, that's what it is. Tell you what, let me get the test out in front of me because I think I have the test here. Let me see. Honors. Thought I had it. Well, goodness. Let me try again. I must have skipped over it. I thought I had it out. Maybe I didn't have it out. Oh, there it is. Yeah. Must have just missed it. There it is. So that ensures, yeah. Yep, so you have one that looks just like this. Numbers could be different, but it looks just like that. All right. This one right here, what do we do here? This time you got diagonals. What do we know about the diagonals in order to ensure or make it a parallelogram? These must be what to each other? They bisect each other, right? So that one and that one must be equal, and what else? That one and that one need to be equal to each other. Agreed? All right. If they are equal to each other, then the thing would be a what? Parallelogram. All right. So again, you just set them equal. Pretty simple. There's no substitution on this one, is there? It's just pretty easy. You just solve for B here, solve for A here, and there's your A, there's your B. You plug it in, and you're good to go. Let me see. Yep. And I do. I just ask for X and Y, and you're fine. All right. What about this? Now the math on this is a little bit more difficult, but it's that substitution thing. Because look, you got an A and a B here, don't you? So again, it's the same geometry, same exact geometry as the one we just did. These two would be equal to each other, so you set them equal. So here, I'll do a little bit of this for you. So 6A minus or plus B equals what? 25, right? Because those would be equal. And then this and this would be equal to each other. So what do you do with that? 12A what? Minus B equals 20. Now you could do this by substitution, but I think, did we talk about elimination the other day? On Friday? Was it Friday? We have class Friday? Yep. So this is set up perfect for you to do elimination. Do you remember elimination? If you put the equations at the top of each other, line up the A's, line up the B's, line up the just regular numbers, the constants, what can you do with those two things? Well, you're not going to subtract, just going to add up. Okay, you're going to add up the columns, right? I'm not going to talk about like why that's true and all that, but back in Algebra 1, we said if you have something like this, you can add up all the columns. Add up the left side, add up the right side, and you're allowed to do that in algebra. So what do you get for the A's? 18A. Now, why did you add up these? Look what happens. Plus B minus B does what? Cancels out. It eliminates, right? That's why we call this method what? Elimination, right? Because it eliminates. It goes away. It cancels out. Equals, what's that going to be? 45. And, oh, this doesn't come out very pretty, does it? But that's okay. Did I do this right? 6A plus B equals 25. 12A minus B equals 20. 45, 18, cancels. Yeah, I guess we did. So 18, 18. Let's see, what goes into 9 goes into both of those, right? 9 goes into this how many times? 5 times. 9 goes into this, what? Twice. So that's your answer for what? A, 5 over 2. Or you could say 2.5, right? If you wanted to. But if you just wanted to leave it 5 over 2, excuse me, that's perfectly fine. It looks wrong. Why is that? Yeah, it's improper. See, I think your elementary teachers, middle school teachers kind of do you a little bit of a disservice because they always harp on taking that and changing it to a mixed number, don't they? It's not a bad thing. I'm not saying that's a bad thing. But they need to explain to you that there are times when it's better to leave it a improper fraction. Okay, especially when you're doing algebra and you're going to work with it, you're going to do some stuff with it. Sometimes it's a lot easier to work with 5 over 2. You could have written 2.5, or you could have written what? 2.5. You could have put that into a calculator if you wanted to. All right, it's fine. I don't mind you doing that in here. All right, and you would have got 2.5, and that you're good to go. All right. Now, what about B? How would you solve for B? Well, you know what A is, right? So you're going to take either one of these equations. It doesn't matter if you take this one or if you take that one. It does not matter. Which one do you think might be the nicest one to pick? Yeah, I probably would pick the top one too. So what do? You go 6 times A, which is 2.5. What's that? Plus B equals 25. So what's that? Well, 2 times 6 is 12, right? Half of 6 is 3. 12 and 3 is 15. So then you subtract 15 from both sides. Can you do that in your head? Maybe. If not, no big deal. What can you do? Use what? Use calculator, okay? But that's 15. 25 minus 15 is 10. And there you go. There's your answers. We good with that? All right. And again, you might see something like this. You don't see that exact problem on there. You will see something that looks more like 4. But it's the same thing, except instead of dealing with the diagonals bisecting each other, what are you dealing with here? Dealing with angles, aren't you? So in order to ensure that this is a parallelogram, what would be true about this angle and that angle? They must be equal to each other. So I shouldn't say they must be equal to each other. If they're equal to each other, then this and this would be parallel. Okay? So what do we do to those? Set them equal to each other. So let's put the x first. So 2x plus 5 equals what? 3y. Then you come over here and look at these. What would this have to be equal in order for that to be a parallelogram? This would be equal to what? X, that's correct. This one right here. See that? Why? What's the reason? You don't have to write that down, but I'm just curious if you knew. Yeah, okay. Two parallel lines cut by transversal. What? That's what I'm looking for. Alternate interior angles. Very good. All right, so if these alternate interior angles are equal to each other, then these two lines would be parallel. If these two alternate interior angles were equal to each other, then what? Then these lines would be parallel, correct? If that's true, so if we can find an x and a y that makes that stuff true, then that means that these are parallel, which means it's a what? Parallelogram. You get it? All right. So we got this first one right here. What about this one here? Again, let's put the x first. So what would I say? Just x equals, right? X equals what? Y plus 5. I think this is set up perfect for you to use what? Substitution. Substitution. So you kind of know what x is, don't you? I'll let you do the math on this. I'll just start you off on it. So x equals y plus 5. So what are we going to do with that? We're going to replace it with a what? Y plus 5. So it's going to be 2 times y plus 5. And then you just finish off the rest of this equation right here. Plus 5 equals 3y. Do the math, right? You can do that. I'm not going to do it for you. You do the math, solve for y, boom, it's right there. We good? All right. Go ahead. Say what? Oh, well, then you find y, and then you plug it in for this, and it's just y plus 5. Okay, so whatever y is, x is just that plus 5. Okay? All right. I'll let you do that on your own. It's on a quiz. I gave you the quiz back, right? You probably got the answers on the quiz, so I don't have to do that. All right, what about this? Find each length. And this time we know it's a rectangle. They say in rectangle PQRS. So they tell us it's a rectangle, which means we know we got right angles in here. We also know what? What's true about the diagonals of a rectangle? They don't just bisect each other. I mean, they do. It's true because they do that with every parallelogram. But what specifically do they do to each other, or what specifically is true because this is a rectangle and not just an ordinary parallelogram? They're equal to each other. That's right. Okay, so PR and QS are equal to each other, and they do bisect each other as well. So really, what's true about all four of these little ones? Okay, they're all equal to each other, right? So I take the same thing and the same thing, bisect both of them. All four of those are going to be equal to each other. So we got to find QS. QS is that whole thing. It says that PR is 12. So if this is 12, what's QS? It's going to be 12 as well. All right? Simple. No math needed. What about this? PR. PR is that whole thing right there. And it says QT is 5. So QT, that's 5. So what's TS or ST? That's 5. So what's the whole QS? It's 10. So if QS is 10, what's PR? That's also 10. Super easy. Super easy if you know that the diagonals of a rectangle are equal to each other. All right? If you know that's true, then it's super easy. All right, rectangle again. So what do we know? Well, let's do that. Let's just go for this. It says it's a rectangle, and we want to find angle 1. Now, remember, it's a rectangle, so all of these angles are right angles, correct? So I want to find angle 1. What do I know about angle 1? This is easy. You didn't even have to know anything about this being a rectangle. Yeah, all you had to know is that it's a parallelogram, really, didn't you? All right, because I got parallel sides right here. So 1 and 35, they're equal to each other. Why are they equal to each other? We just talked about it. Alternate interior angles. No math involved. Boom, 35. All right, so if angle 1 is 35, what else do we know? What do you know about this angle right here? What is it? That's also 35. Okay. What about this angle right there? Okay. You got it. Okay, so take those two, add them together, which is 70. Take it away from 180, 110, and that's what angle 3 is right there. Okay. Well, you can see that these two triangles, this one and this one, are congruent to each other, correct? Here's a better way. You don't even have to go that route. You know that this side and this side to that triangle are equal. So remember, if you got two equal sides, then the opposite angles are equal to each other. So if that's 35, that has to be 35. It's a good question, though. We good? All right, one more. Find the measure of each angle in a rhombus. So first of all, what's a rhombus? They marked it for you, so that they made it kind of easy for you. So the rhombus means all four sides are equal to each other. How? Well, let's just do this. EFG is what we're looking for. So we're looking for this big angle right there. Well, I don't know anything about this angle, do I? But what do I know about the diagonals of a rhombus? They specifically do something that they don't necessarily do to a parallelogram, and they don't necessarily do to any old rectangle. They bisect the opposite angles. Very good. All right. Now, are all 4 angles of a rhombus equal to each other? No, because this is acute and this is obtuse. There's no way that all 4 angles are equal. But you do know something about the opposite angles. The opposite angles are equal to each other, okay? So those 2 would equal, and these 2 would equal. I'm not really sure if that comes into play right here, but let's just keep going and see if they do, all right? So where do we start? Well, actually, it's not the only angle we know, but it's one of them. So we know this is 60 right here, so we're definitely going to use that. There's another angle that you know. What's angle 5? Got to know something about a rhombus. This is something we talked about. What's angle 5? Why 90? Because they're perpendicular. That's right. The diagonals on a rhombus, okay, are perpendicular to each other. So this is 90 degrees, which means that's also 90 degrees, isn't it? So if that's 90 and that's 60, what's this little angle up here going to be? That's going to be 30. Just go 90 minus 60. Remember that if you have a right triangle? You could go 180 minus 90 minus 60, but why bother? Because you know you're always going to go 180 minus 90, correct? So just go 90 minus 60, which is what? 30. But that does it help me with EFG? Sure it does. Because I want to find that whole thing. Remember, these angles are bisected. So if that's 30, then what's that? That's 30. The whole thing is 60. Okay? Angle 4, what do I know about that? They're the same as they are up here, right? Because the opposite angles are equal. It's being bisected, so the opposite angle, so the whole thing is 60. If it's being bisected, that's 30. That's 30. And so there you go. When I said the same thing, I meant the same thing as these 2, not the whole thing. All right, so angle 4 would be what? 30 degrees. Make sense? Yeah. All right. Let's go a little bit further. That we didn't take a quiz on this next stuff. All right. Now, I'm not going to do that coordinate geometry. Okay, we did that already. But you do have some other problems. 3 sets of problems. So from 14 to 18, you have some problems that we did not have on a quiz. And what did that cover? It covered 2 subjects. So we did parallelograms, right? We did rhombus, we did rectangle. Yeah, we really didn't talk about a square, did we? But that's in that whole category, though, of a rhombus and a rectangle. What was the next thing in the next couple lessons, or actually the next lesson, probably 6.5 is my guess. Do you remember what we talked about? No, before the coordinate geometry stuff. What is it? Kites. Okay, kite was one of them. And what else? Say what? Trapezoid. Very good. That's what I'm drawing right here. All right, so that's trapezoid. So let me just go through a couple things about the trapezoid. We know the trapezoid has exactly 1 pair of parallel sides. Okay, does that mean they're equal to each other? No. Okay, it's obviously shorter than that one, so they're not equal. These are not always equal to each other, but you do have a special type of trapezoid. You remember a special type of trapezoid? Isosceles trapezoid. And I did not put an isosceles trapezoid on the test. Okay? So what do I know about this angle and this angle? They're supplementary, which means they do what? Add up to 180. Okay, so I'm not going to put any numbers in here, right? I'm just going to let you know. Okay, so these would be. Hold up, I lied. Sorry. Those are not necessarily supplementary to each other. This one and what? This one. Why are they supplementary? You don't really have to know that for the test, but it's good to know. Well, I got parallel lines cut by transversal. So which one of those am I going to use? Give me a good word. What word? It's not alternate interior. They are adjacent to each other, but that's consecutive interior angles. That's right. These are consecutive interior angles. So what's true about them? They are supplementary. Okay, so this one and this one are supplementary, not necessarily this one and this one. By the way, could these two be supplementary? Because look at it. No, because that's obtuse, right? And that's obtuse. Can you have two obtuse angles being supplementary? Not just because the definition of obtuse means it's what? More than 90. Could I have one angle that's more than 90 and another angle that's more than 90 and they add up to be 180? No, I couldn't have that, all right? So these would not necessarily be. But this one and this one, yep, they could be supplementary. And not just could be, they are. Absolutely 100%. They're supplementary. Same thing with this one and this one. You got it? Okay. So make sure that you understand that for that. So that would be numbers like 14 and 15 on the test. Not that it matters, but that would be 14 and 15. Then we did something else. We did this. We found the midpoint of these two legs, right? Remember that? Okay, so there's the midpoint. And then we drew a line that connected those two midpoints, and we gave it a name. Do you remember what that name is? Mid-segment. Very good. That's pretty close. All right. So you do have to know something about that. So this is a midpoint, so that means that this little bit and that little bit are equal to each other. This is a midpoint, so you know that and that are equal to each other. So what was the relationship? But let's just throw some numbers in here. What's a good number right here? Like 5, okay? What do you think that's going to be? 15? You think this is 3 times bigger than that? Maybe 10. Let's do another number just to make... I'm picking a number that makes this come out a little nicer. Let's just say it's 7. Is that all right? Yeah, so let's see. All right, yeah, let's start here. It's not exactly the way it's going to be on the test, all right, but it's going to lead us to that. So what if I ask you to find that one right there? Just add them up and do what to them? Divided by 2. That's 12 divided by 2, which, like you said, is 6. All right, watch this, though. What if I didn't tell you that? But I did tell you that was 6, and I asked you for that. Now, I made it super easy. You already saw what it is, all right? You know what it's going to be. But I could put some other numbers in here, okay? Some bigger numbers, maybe not ones that you could just look at and say, oh, yeah, that's what it should be. So what's the math you would do to do this? Okay, so here's what I would do. Watch. The mid-segment, I'll call MS for mid-segment, is equal to what? It's equal to those together, right, over what? 2, right? How do I find this? I take this one plus this one, and then I divide it by 2, correct? You guys nodding along? Anybody? All right. Looks like you're lost. I don't know. Are you lost or are you just okay? Keep going, Mr. Hamrick. All right. So, but this time, look. I know the mid-segment, don't I? So what am I going to do with the mid-segment? Put it in here. What is the mid-segment? It's 6. So now, there's my little math equation, and now I just got to solve for x. So how do I solve for x? Got to get rid of that 2. What do I do? Multiply it by 2. Multiply that by 2. So what do I have? 12 equals, that cancels, what? X plus 7. Now what do I do? Subtract 7, and what's x? It's equal to 5, just like we said it was going to be. Agree? Now, on the test, the numbers aren't going to be quite as easy as that, but they're just going to be numbers. There's no x or y or anything like that, okay? I'm just going to give you numbers. So, I'll tell you right now, on the test, I give you the mid-segment, and I give you one of the other bases. Got it? And you got to find the other one. How do you do it? That's how you do it. All right? How do we start it off? Add the top one and the bottom one, divided by 2, and that equals this. So that's what I did. I added the top one and the bottom one, divided it by 2, set it equal to the middle one. And now I just do some math, and I solve for x. We good? Stop me if you need to. All right, let's do another one. Last little bit. So we did trapezoid. What are we going to do now? Kite, yeah. So let's draw like this. Let's draw like this. And that's. Actually, on the test, they don't even give you any of this crossbar and axis of symmetry stuff. But it helps me draw a nice kite, though, doesn't it? Putting those two things in there, make sure they're perpendicular, and all that good stuff. All right. So what they're going to do, well, let's just talk about this for a second. They'll tell you that these two are equal to each other. So if these two are equal to each other, what's true about these two right here? They also have to be equal to each other. Now, which angles are equal to each other here? Let's just call this A, B, C, D, just so we can talk about the angles. Which angles? A and C. That's correct. All right, so A and C are equal to each other. Oh, yeah, it's easy. Okay, so I'm going to give you one of them, and I ask for the other one. All right, it's almost not even worth putting on a test, is it? All right, I don't know. What do you think that angle is, right? Let's just make something up. What do you think? It's what? It's 5. This angle A, 100. All right, looks a little more than 100, but we'll put 100. Okay, so if this is 100, and they give you another one, what do you think this is? That looks about, it's almost 90, isn't it? Pretty close. 80? Okay. Might not be drawn exactly to scale, but that's okay. So they're going to give you something like this, and they're going to ask you to find the other two angles. It's as easy as that. What's the easiest one to find? C. What is C? It's 100, right? That's all you got to do right there, because you know these two angles are equal to each other. Now, how do I find this one right here? That's good. Take it away from 360. So let's add these up. 100 and 100 is 200 plus 80 is 280. So what do we do to find the fourth one? We subtract it from 360. What did I say? 280? What's that? 36, 8? 80, right? No? Did I do that right? I think it's just because we didn't pick very good angles here. Because that definitely doesn't look 80 degrees, but that definitely doesn't look 100, does it? Tell you what, let's make it a little nicer. Make it look a little more to scale. So it looks a little more than 100, don't you think? 135? All right. I'm okay with that. 135. So now let's see. 135 and 135 is what? 270, correct? Plus 80 is, what's that? 350? Is that right? 15? Yep, 350. All right. Now you can do the math in your head now. It's pretty easy. How do I find this? Take 360, do what to it? Minus that, 350, which is 10 degrees. Again, it looks a little more than 10, but that's probably not correct anyway, but we're good enough. That's how you would do it. Everybody can do that, right? Except for Xavier, because he's sleeping through this whole thing. See the basketball pictures I put up? No. I got some of you on there. Got some good shots of you. Better look at them. You know how to get to it? Okay. You don't want to look at them? Dude, I specifically tried to get pictures of you playing, and I picked them, and I edited them so that you could see them, and you're not even going to attempt to look at them? All right, I'll delete them then from the album. Is that all right? All right. Then 19 and 20. So that would have been 17 and 18 right here. Okay. And then 19 and 20. We already did that the other day. And that's that coordinate geometry stuff. Okay. So 19 and 20 is like that. I'm not going to take any more time with that because we already discussed that. All right, there you go. There's the whole test. Took 2 days to review for this thing. All right, I don't normally do that. I shouldn't even take a full day to review for it. It should just take like half a class period. But anyway, I took 2 full class periods to review this with you. So I expect good grades tomorrow. Don't you? Me too. All right. Any other questions? I mean, I pretty much gave everything. I went through every single problem and gave you examples of every little problem. I didn't do the problem. I didn't necessarily do every single problem, but at least I explained to you what they are, so you go back, look at them, and be ready for it. Okay?